Okay, today we're going to talk about chemical reaction types. In the last lesson, we talked about going from word equations to formula equations. And now we're going to identify those formula equations into the type of chemical reactions that we have. We're going to learn 5 chemical reactions in this class. So first of all, we need to know what is an evidence. How do we know that a chemical reaction occurred? And we know this from one of the first units we talked about when we talked about chemical change. How do you know there is a chemical reaction that occurred? Well, one of the main things is you have a change in energy, and that energy can come in many ways. You can have a change in temperature. For instance, if your temperature increases, you have an exothermic process. You feel heat. That's evidence that you had a chemical change. It got warmer. Or, for instance, if your temperature gets colder, you feel like if you touch it, it's colder to the touch. Your temperature decreases, that's an endothermic process. That's a sign of a chemical change. You see light where there was no light before. That's a sign of a chemical change. One of the big ones is a precipitate is produced. So you're starting with some liquids. You mix them together and all of a sudden you see a powder or something at the bottom of your test tube, at the bottom of your beaker, where there wasn't any before. That's called a precipitate. If you make a precipitate, that's a driving factor. That's a driving factor for a reaction to occur, and it's a sign that a chemical reaction occurred. If all of a sudden your color changed, you were red and now you are blue. You were clear and now you have a purple color. A change in color is a sign of a chemical reaction. If you see little bubbles, you produced a gas. These are all signs of chemical changes. Forming a gas, forming a precipitate, those are all driving forces for reactions, and we'll talk about that in a little bit. There are 6 types of reactions that we're going to talk about in this class. There's combination, which we also call synthesis. That's one. There's decomposition. There's single replacement, there's double replacement, and there's combustion. And we're going to go through each of these individually. We also have redox reactions, and this is something that we will talk about only in pre-AP chemistry. There are more reaction types than these, but these are the ones we will focus in this general chemistry course. The first reaction type we're going to talk about is synthesis or combination. Synthesis is where you have 2 or more substances that combine and they create a more complex substance. You're making one thing. You're making one product. So you have 2 or more things making one. So when you're trying to find a synthesis or combination reaction, know that you are looking for one product. Multiple reactants, one product. And its general form looks like this. It's a very basic one. You have an element A or compound A plus element or compound B to give you AB, one product. You could have something like an A plus B plus C, and that would give you an ABC. But the point is you have one product. So you can see what that means just like looking at these 2 people. You have 2 individuals. Now they get together and become a couple. You made a new product, a new couple. An example of a synthesis or a combination is sodium plus chlorine, 2 things, sodium plus chlorine, to give you sodium chloride, making one product. So let's try a few of these. We're going to predict the products. We're not going to balance right now because we haven't done that yet, but we're going to predict the product for these things. So we've got sodium metal, and it reacts with chlorine gas. We're going to have to do this on the whiteboard because we have to change this word equation into a formula equation. Okay, this is sodium metal reacting with chlorine gas. So we have to write this out as a formula equation. Sodium metal. Sodium is monoatomic, so we just write Na. It is a metal, so we're going to put a little S to denote that it is a solid. It's reacting with, that's plus, chlorine gas. Chlorine is a Cl. However, this is one of those diatomics, so you must write Cl2. Chlorine exists as Cl2, and this is a gas. Okay, so now I'm telling you this is a synthesis combination. In other words, we're going to put these two things together to make one product. So we're going to put sodium and chlorine together. Because sodium is a metal and chlorine is a nonmetal, we're going to make an ionic compound. So we have to worry about our charges. We have a sodium that is a plus and a chlorine that is a minus. You're going to crisscross or balance your charges, and you're going to get sodium chloride solid. The next problem we're going to try is solid magnesium reacts with fluorine gas. So again, solid magnesium, that is monoatomic, so we just need to write Mg and an S to say it's a solid. It's going to react with fluorine gas. Fluorine is not F, it is F2 because it is one of those diatomics. We're going to be putting this together to make a ionic compound, magnesium plus fluorine. Well, magnesium has a charge of +2, and fluorine has a charge of -1. You put those two together, and you get magnesium fluoride, MgF2. The last example we have is aluminum metal reacting with fluorine gas. So aluminum metal, this is a metal, it's monoatomic, so we're going to put an ALS. It's reacting with fluorine gas. Fluorine, again, is diatomic. Okay, and we're making a combination or a synthesis reaction. So we're going to put aluminum and fluorine together. Aluminum has got a charge of +3. Fluorine has a charge of -1. You crisscross, balance your charges, whatever works for you, and you end up with an AlF3. So this is synthesis or combination as a whole. The next reaction type we're going to talk about is decomposition. Decomposition is where you have a more complex substance, something that has got a bunch of stuff that are bonded together, and they're broken down into more simpler substances. They're decomposed, broken down into its component parts. Decompose means to break down. So what you're doing for decomposition is you're looking for one reactant. That reactant is going to break down to produce its products. That's a decomposition. For instance, decomposition can have a general form of AB yielding A plus B. It broke down. So it's kind of like if you have a relationship, you have a couple and they break up, their relationship decomposed, it fell apart. That is what decomposition looks like. You can have decomposition where you have ABC yielding like an AB plus a C, but it's still decomposing to smaller parts. Again, you are looking for one reactant. To remind you, for combination or synthesis, you are looking for one product. Decomposition, one reactant. So what does that look like? Let's practice. So we're going to decompose these, and we're going to put this on the whiteboard. Okay, an example of decomposition. Solid sodium chloride. Sodium chloride is an ionic compound. So we have an Na plus and we have a Cl minus. That means we started with an NaCl. This is a solid. We are going to decompose. We're going to break down. So we're basically going to cleave this right here. We want to have sodium by itself, and we want to have chlorine by itself. Well, we just write Na for sodium because it is monoatomic. For chlorine, for the Cl, we don't write just Cl. We have to write Cl2 because it is diatomic. If we were to go to balance this, which we will talk about in a couple units from now, you would put a 2 here and a 2 there to balance. Okay, here's another example. Solid 4-oxide is going to decompose. What does it decompose to? Well, first of all, we have to figure out what solid 4-oxide is. Well, we know solid lead 4-oxide is. We know that lead is Pb, and this 4 means it's got a charge of +4. Oxygen has a charge of 2 minus. So if we were to put that together, balance our charges, and or crisscross and reduce, we end up with a PbO2. Now we want to decompose this. So we're going to want to cleave this right here. We want to have some lead and we want to have some oxygen. Well, we'll write we should put an S there. Pb, that's your solid. And then we have to have oxygen. Oxygen is a diatomic, so it needs a 2, and it is a gas at room temperature, so we would put a G there. The last one we're going to do is aluminum nitride decomposing. Well, we know that aluminum is a +3, and nitride is a -3, N -3. So if we were to put those together, we get an ALN once we've balanced our charges. This is going to decompose. So you're going to decompose to aluminum. It is monoatomic, so it's just Al plus nitrogen. But nitrogen is diatomic, so you must write an N2. So let's review what we've learned so far. We've learned 2 reaction types. We've learned synthesis/combination, and that is where you start with 2 or more substances and you make one product. You're combining things. You're making one product. So if you're doing synthesis, you are looking for that one product. If you are doing decomposition, what you're starting off is with one reactant and it's breaking up into something smaller. So for your decomposition, you are looking for one reactant. Synthesis is one product. Decomposition is one reactant.